Okay, hope everyone is well and making progress. Before I start in on this, I did cancel sort of the practice run through on the test because there was, up until about last night, there was some back and forth about proctoring and everything. So, oh good, here he is. Okay, I had received a message. Welcome, Hunter. I had received your message and I was, anyway, good to see you made it into class. So the, where was I? So Monday, we will do a run through. What I've got is that the test will become visible and as well as the link in Canvas to download it at about class time. So we're going to do this again on Monday. Things actually will become available about like 15 minutes before class time. So if Monday you want to come on in, we'll get things set up and we'll just kind of do a quick run through to see how it is for getting everybody up and running in the test so that we don't have, hopefully we figure out any problems and get them fixed on Monday so Wednesday is nice and smooth for us. Okay, so come on into class on Monday and we'll keep it going. Okay, and I've just tried a waiting room thing. So I guess when you first come into class, it puts you into the waiting room and then I'll click and let you in. So here we have for 12.6, remember this is dealing with the demand function. And when we're looking for elasticity of demand, what we're using as elasticity of demand is the derivative. It's the derivative of Q times P over Q. Okay, I think, and so maybe this notation will be a little bit, I've also called this F of A, but it's just basically Q. So we're going to need this derivative, right, to find the elasticity of demand. So let's find that first. So the derivative of Q. This 100 is just a constant multiplier or divider. This is a constant number. So this one we actually use the chain rule. The 2 comes down in front. Okay, so when we take the derivative, we're taking the derivative of this whole parentheses. The 2 comes in front times the original. Right? We subtract 1 from the exponent, so now this is to the first power. And then we use the chain rule. Let me, it's all still over 100. We use the chain rule. We take the derivative of the inside, and the derivative of the inside is just negative P is -1. Okay, so what we're going to get is that Q prime, notice the negative will come front is 2, the 2 goes into 100, so it reduces down to -311 minus P over 50. And then I guess we could distribute this negative. So that's going to be -311 plus P over 50. So that's our derivative. We're going to use this as our derivative. That goes right there. So we're going to do -311 plus P over 50 times P, which is this one, over Q. So then we get 311 minus P squared over 100. There's a way that I can, let me just see. Yeah, we'll see. Okay, so we've got a fraction with a fraction in the bottom, a fraction sort of over a fraction. So this is like division. What this ends up being, actually, let me do it this way. It's like p divided by 311 minus p squared over 100. When you divide by a fraction, you flip and multiply. So this is going to be p times 100, right?
Hey, did you guys just start now? Is this the first question?
Yes, it is.
Okay, sorry.
It's okay. So then we're going to have 100 times p. Okay, so I've reworked this part here. And it's all going to be over 311 minus p squared. I'm going to, well, tell you what, since I'm looking at this, I'm going to factor back out that negative. Simply because I can see that I can basically cancel out that term. Okay. So now with multiplying, (311) minus p cancels with one of these because there's, right, it's squared. There's still this negative. 50 goes into 100. That cancels there, leaving 2. So in the end, we've got this minus 2p in the top. And 311 minus p in the bottom. So that's our elasticity of demand function. And what happens when we set the price at $32? Well, now we just plug in 32 for p. So we get minus 2p, 2 times 32, 311 minus 32. That's going to be negative 64 in the top. 311 minus 32. Let's go ahead and need this anyway. 279. So 64 divided by, wait a minute. I did it again. This is negative p, because remember, demand always reduces. And the way I saw that is we ended up with a negative answer. So we've got this negative here, we've got another negative, so that makes this a positive, that'll make this a positive, makes this a positive, that makes this a positive. Okay. But still 64 divided by 279. Gives us 0.23. Right, we round your answers to 2 decimal places, 0.23. And I think I still have the question here. Let's test this out. So what does that mean that we've got? See if I got everybody from the, there we go. What does it mean that I've got 0.23? It means it's inelastic, and it means I really should move the price up. But let's go ahead and check it. Just to be sure. Yeah, okay. So just remember this function. Now, while you don't get a use notes on the test, I would have this formula in like a note card. In fact, I'd have all the important formulas. This is definitely one thing I would have. And remember, Little Crow keeps forgetting this negative. If you're like me, maybe make a really big negative there and remember that one. Okay. So that works. Find the price at which the publisher should sell the books to maximize weekly revenue. Okay, so now that we've got the correct function here, what we want to do is we set that equal to 1.
Could you scroll up for 1 second?
Sure. And by the way, this is 12.6 question 5, and it is recorded, so we can always go back and review it. Okay, so it's going to be equal to 2p over 311 minus p. And then again, since it's equal to 1, we sort of do this cross multiplying thing. Think of this as 1 over 1. So we end up with 2p on one side, 311 minus p on the other, and then we just solve for p. So I would add p to both sides. Oops, p gives us 3p on the left, 311 on the right, and then divide both sides by 3. Gives us p equals 311 divided by 3. $103.666. We'll go to 367. So it'd be $103.67 is the price that will maximize revenue. And notice that's sort of what this told us. This number is very far away from 1. So the $32 was way too low for what it should have been. Okay, $103.67. And while we're at it, so find the price at which a publisher should sell the books to maximize weekly revenue. Round your answer to the nearest cent. While we're here, let's just go ahead and check it.
Hi, I have a question about the test. 2 questions, actually.
Okay, how about after we finish working this one, though?
Sorry.
Okay, so that's correct. And now we need to get the to the nearest dollar. What's the maximum weekly revenue the publisher can realize from this sale? So to get the total revenue is always price times quantity. So now we know the price here. The quantity is going to be from the formula. So P is 103.67. Q, come back up here, is this original equation they gave us. So it's 311 minus P squared over 100. So 311 minus P, which we now know is 103.67 squared over 100. So now we just do the math on this one, the arithmetic. So let's go 311 minus 103.67. That we want to square it and then divide that by 100 and then multiply that by 103.67. So our revenue $44,563. Okay, and it said the nearest dollar, so we rounded it to the nearest dollar there. Just put that in, it should be good. 44,563. So use the, there we go. So then again, I'll save this to my desktop. And then I'll upload it along later. 12:06, and this was question 5. Okay, so before we move on, was that helpful, or any questions on this particular one? Okay.
I have a question.
Okay.
A, how many questions will be on a test? And then B, is it like multiple choice for all of them, or?
There'll be 13 questions on the test, and they will be fill in the blank answers just like the homework. In fact,
Okay.
the questions are actually taken from the home. They're from the same test bank, so it'll be like doing a homework assignment. The ones they've chosen, I'll just tell you, are not the, as how the homework is sometimes the first few ones are pretty straightforward. Sometimes the last ones are pretty involved. They're mostly either at the earlier level or about mid-level. But so a good way to practice is going through these homework problems. Is also, there is of the 13 questions, they're all from different things. There's a, what do we have? We've got a second derivative, we've got a chain rule, we've got a natural log, we've got an exponential. Basically, each of the questions is out of something different. There's 2 questions that are basically on the same topic, and that's on the point of inflection. So point of inflection, there's 2. Everything else, there's only 1 question on each topic that we've covered.
And then also, just to clarify, it's going to be like on a lockdown browser with Canvas, but then we take our phones and then log into a Zoom meeting.
Actually, we won't be using the lockdown browser because the lockdown browser cuts Zoom out. So you'll just come into the Zoom meeting. The test has a password on it. I will give you that password, and then you'll just start into it. You can have Zoom on your computer. Those of you who don't have a webcam or don't have a webcam, then you could use your phone, come into the Zoom meeting through your phone. Yes.
Thank you.
And we will do a run through on Monday. It's not really for any points, but I think you're going to find that if you go through it on Monday, I've got a dummy test set up with 1 question. I have a location in Canvas for you to upload a PDF file. So we'll do a 1 question test, but it's mostly just to see if you can get through the process of putting in the password, opening up the test, getting ready to take it. When you finish, taking a snapshot of some notes and then uploading them into Canvas, because that's how we'll have you do it. That's how we'll get you the partial credit. And we'll want you to be able to upload the notes right after the test.
Hi, I have a question, but it's for the prep test that's on Canvas,
Okay,
number 4.
number 4. Have you watched the videos on those?
Not yet. Do you go
Okay. Yeah, I got videos where I did go through all of them, but I'm still happy to work them here. But do watch the videos. I know it's about 4 hours of video, but I did it by the sections in there. So just so you know that there's, each of those problems, I worked all of them.
Perfect? Thank you. Then I'll go ahead and do that. Thank you.
Okay, you're welcome. And then, if you've got afterwards, if you still have questions, I'll be happy to go over them. But I went pretty thoroughly through them. I was getting tired towards the end because I did spend a day, and it was about a 12-hour day by the time I was done. And maybe I should have stopped at about 8 hours, but anyway, you'll see. Okay. In fact, actually, let's see, I'll show you. So, and I put them all, can you still, no, you can't see my screen, can you? Let me come back. Okay, back to the screen. So where they are is this is in Canvas. Actually, you'll see mine. You'll see this on Monday. This is where I got the exams and such. So this won't be visible to you yet. Let me go to student view and I'll show you what's. Actually, you can see it. You just can't. Well, anyway, you weren't supposed to be able to see it. So I've got the study guide videos right here. Test 2. I've got the 11, 4, 5, 6, and 12, 1, and 2, 3 are right here. The last 3 sections are here. So if you click on this, it gives you. I saved them as a PDF or a doc file where you can actually see all the where I worked through them. That's not a video. It's just so you might pull those up first and see what the solution looks like. And then in here, I've got these videos, and like this one is 13 minutes long. It's going through the section 11.4 questions. This goes through 11.5, and it's almost 20 minutes long. And then they got longer and longer. This one's 22. This one was almost an hour on the locating extrema. And this one was 45 minutes. And again, the last 2, I wasn't mentally as sharp, but I did show the correct processes. And because we had the answers there, I was always able to check. So there's video solutions for all of them. And we go back just to show you 12.3, 12.5, I put in a different one because I did those actually first. Again, they're the numbering's a little off because when I did this when I made these up, it started numbering 12.3 from number 1, but it's the same problems from the study guide. And as you see, what I did is I went to the PowerPoints, and I took basically I tried to take 1 or 2 slides that basically summarize that section, did a little bit of overview, and then I worked through each of the problems. So those are all there. And again, having seen the test as well, I can tell you these questions, he took them when he makes these up, the coordinator. I could tell some of these questions he had obviously used WebAssign to take them out. They're very, very close. You'll be in good shape by going over this review. And then again, there's also in WebAssign itself. Let's see, where it is. There's also the review test in there. see if we come here. So review for exam 2. And again, you've got to just see how much time you have, I know, but this has 41 problems, but it would be a very good review because this is much like what the test will be. It'll only be 13 questions though, but it's a similar type format. And again, during the test, it will not tell you whether you've got them right or wrong. But in the practice test, you can put in answers, it'll check them, you can see what you're right or wrong. And in fact, the test, you won't see your score right afterwards because I've got it set not to show up until after I get a chance to review everything. And then the test itself will become available to you on Saturday. Oops. Okay, what else? Any other questions? Any other? Yeah, so this, we're going to use this online testing resources on Monday. There'll be a practice run through and we'll take it through this. There is, if at this point the online testing instructions, it would be kind of good. Some of the other professors came up with this and I've adapted it for WebAssign. So if it says Alex in here somewhere, because that's really the people that made it, just substitute it with WebAssign. I think I caught it all, but basically this is the process we'll go through, and the proctoring will be through Zoom. We'll have all of you up here. I can view 25 at a time, and I'll be going back and forth between the screens. And it'll be like this, except, you'll just need to have your video on. And again, if you don't have video on your computer, use a cell phone camera. You can download the Zoom app beforehand. We just need to have video confirmation that it's you taking the test. And again, follow the instructions as far as, realizing what's allowed, what's not allowed. Oh, here we go. Lots of questions. Okay. Are we still taking exam number 3? So the question on exam number 3, yes and no. The exam date, the thing that's called exam 3 is canceled. It's moved to the final exam time. So instead of taking the final, which was going to be comprehensive, we'll be taking what would have been exam 3. So exam 3 will cover everything after exam 2. So basically when we start into chapter 13, the parts of 14 that we're going to do, that's what exam 3. So there will not be a comprehensive exam. And then the other question is, so when we take the test, once you finish the test, that's when you take a picture of your notes. And then you upload it. It says within 30 minutes. I'm not going to, don't get stressed out about that, but do get it done relatively quickly after you finish the test. And it's either a student ID or if you don't have your student ID with you, a driver's license will do it. They say have the audio on while taking the test. I think that's, we'll have it on at the beginning, but I'm going to mute you all pretty quickly because if you're like me, I talk to myself when I'm taking a test, and there's going to be sounds and such. So I just left the notes that they have, but I'll just be honest, within a few minutes into the test, I'm going to mute you all anyway. They just say to turn off your audio so you guys don't hear it, but I don't, yeah, so we won't do that. But we will, you do need to make sure that your video is showing you at all times. And that's how we'll be doing the proctoring. 12.5, number 4 and 5. Let's take a look. Oops. Let's go home. Let me see if the other thing is I do have from the previous times, I do have some, I recorded those sessions. So there may be other times where we work through things. You may want to take a look at those as well. Four and 5.
I have a question about the study guide real quick in regards to the test. So this exam to review study guide that's available online, that's still definitely relevant to what we're doing, or should we focus more on the homework then?
Well, it's definitely relevant. And like I said, I've looked at both. Yeah, those concepts you need to know. However, the test is, I mean, as far as the process of doing it, it's like the homework, but a lot of these questions are similar to the homework too. So I would do both. Because I do have videos for all of the study guide. So those are good to go over. But then I would also work through the review exam, which is, again, over here. Well, actually, I've got it down, but yeah, there's about 34 questions there. I would work through some of those. 4 and 5. Let's do 5 first. And I guess I would say at a minimum, I would at least, with the study guide, I would at least review the printed solutions. And if it looks like, hey, you can follow what is going on, that's great. And then maybe then go over and see if you can do it in the online one. The online review test. Because what that does is that'll help you know what you remember, because it mixes everything in together. Okay, so this is 12.5. Spherical party balloon is being inflated with a helium pump at a rate. So remember 12.5.
Can we see we can't see your screen.
Oh, thank you. There we go. How's that? Now do you see what I'm?
Yeah, we can see it now.
Okay, good. So 12.5 is related rates. And the process is basically to find an equation, a formula, something that relates the two or more variables we're talking about. So this one, they actually do give it to us. And on the test, if you need if there is a related rate problem, and they give you the formula as well. So you don't have to memorize geometry formulas. Okay, so we've got a spherical party balloon. It's being pumped at a rate. So this, whenever you see the word rate, that's a rate of change. That's a derivative, 7 cubic feet per minute. And what's changing? It's that's its volume. Okay. And in these related rates ones, we're always taking the derivative with respect to time. So what I can know is that this is the derivative of the volume, dV dt equals 7. Okay. how fast is the radius growing? So we want to know the rate of the radius at the instant when the radius has reached 2 feet. Okay. Okay, so what we do is on these related rates, we've got our formula that relates the two. We want to take the derivative, and when we're talking rate, there's a third variable of time that doesn't appear in here, but because we're changing over time, that's our third variable. So you take the derivative of v with respect to time, so that's going to be, the derivative of v is 1, and we took the derivative of v.
Wait, I have another question. Isn't it r cubed, not r squared?
Thank you, yes.
Oh, okay.
Yes. Good. Okay. On the right-hand side, it is 4/3 pi. Those are constants, so they just tag along. You take the derivative of r cubed. That's the 3 is going to come down and multiply. Subtract 1 from the exponent, so that's r squared. And then we took the derivative of r with respect to time. Okay. So we'll just clean this up a bit. Here's 3 divided by 3, so those can cancel out. We don't really need this 1, so we'll take that out. dv dt equals 4 pi, because the 3 is canceled out, r squared dr dt. Now the question, how fast, that's how fast is it changing? What we're looking for is dr dt. They've given us r equals 2, dv dt equals 7. So that's what we start plugging these things in. So dv dt is 7. Pull this up. We've got 4 pi. R is 2 squared, and then dr dt. So we multiply everything. 2 squared is 4. 4 times 4 is 16. Divide both sides by 16 pi. So that tells us that the r dt is 7 divided by 16 pi. They want it to 2 decimal places, so that tells us we're actually going to calculate it with the calculator. 7 divided by, I'm going to put parentheses, 16 times pi. So our final answer is 0.139. They want 2 decimal places, so we'll do 0.14. Feet per minute. Okay. And again, just to be certain, always good to come here and 0.14, test it out. There we go. Okay. And I'll say that, it's 34 questions in the practice test or whatever it is. You might not want to do them all, but, skip around it and just make sure you do one of each kind. So was that helpful on number 5?
Yeah, that was good.
Yep, that worked.
For number 6.
Number 6 would be one? Okay. Yeah, this is
No, I
number
was just
6.
asking for this. Yeah.
Yeah, number 6 would be identical as far as the setup, just different numbers and different units. They got centimeters instead of feet. Oh, actually, let's see. is filled with a helium at a rate of 13 cubic centimeters. Well, let me set this up and show you the difference. This one, they don't give us the radius. So what you have to do, wait a minute, maybe the flimsy after it reaches an instant, it reaches 7 centimeters. So actually they do, the radius is 7 centimeters when it pops. They're giving us the rate that the volume's expanding. So it's really exactly the same setup, except instead of R equals 2, we've got R equals 7, and dV dt is 13 instead of, what did we have, instead of 7 here. So yeah, it'll be really the same formula. It's just the numbers we plug in will be different. So for 6, yeah, we would start with 13 equals 4 pi 7 squared dr dt. And this will be in terms of centimeters per second. Okay. Or again, you may have different numbers there yourself.
Wait, can you see your screen?
Oh, so thank you. I'll, okay. So I apologize for that. So I was looking at 6. Yeah, you'll have different numbers here anyway, but it really is the same problem. They just gave the information backwards. They gave the radius first, and then they give the rate of change of the volume. Whereas in 5, they gave the rate of change of the volume and then the radius. Okay. So for my question 6, I've got the radius would be 7 centimeters. So I take that same formula. This is the derivative formula. The radius would be 7. For mine, the rate of change is 13 cubic centimeters per second. So that's the dV dt. I put in the 13, and that's how question number 6 would be. Again, just really different with the numbers, but it's overall, it's the same thing. Starting with exactly the same derivative. Okay. What else? Did I miss anything?
Like, can we do number 4 for this one too?
Number 4, okay. So let me copy that one. Let me just get a new sheet. There we go. Okay, so we've got the area of a circular sunspot. So this one, they don't give us the formula, but so we are going to have to remember that the area is equal to pi r squared. That's what that's a relationship between area and the radius. So how fast is the radius growing at the instant when it equals 8,000 kilometers? So that must be the radius. So they're telling us r equals 8,000. They're telling us here the rate of growth. So that's a derivative. and that's the area. So that's dA dt is 1400. Here's R. And so we start off with the formula, take the derivative, and again, this is where we used implicit derivatives, and we're taking the derivative with respect to time. So this derivative of A is 1 dA dt, and I just didn't write the 1. Pi is a constant. When we take the derivative of R, the 2 comes down, so we're going to get 2 pi, subtract 1 from the R, or sorry, subtract 1 from the exponent, so that's 2 minus 1 is 1, and then we took the derivative of R with respect to t. So this will be the formula we start with. dA dt is the rate of change of area, which is 1400. 2 pi is just 2 pi. And then we were told that the radius is 8,000 at this particular instant. We want to know what is the rate of change of the radius, dr dt. So again, we go through the math. This is going to be 1400, 8,000, okay. This will be 16,000 pi. So divide both sides by 16,000 pi. So 1400 divided by, actually, 1400 divided by parentheses 16,000 times pi so that's going to be 0.27. They want it to 4 decimal places, right? And your answer to 3 decimal places. So 0.028. So the 7 gets rounded up. 0.028. But that's in terms of kilometers per second, okay? Kilometers per second. And again, we'll check that just to, and again, when you go through these, you might also want to, you know, practice going through without checking and then check at the end just to, you know, but we got it. I like to picture. The second part of this, though, is a little different. We're told, instead of given the radius, we're told the time of when it has the area, okay? So we're still using this same formula, right? We've got dA dt. We don't have this. We need to have R. So the way we're going to get R for this is what we have to do is first plug it in the original formula up here. That we've got 640,000 square miles as our area. So now we can calculate what the radius is, okay? So we divide by, so this is for the B part, divide both sides by pi, and then take the square root of both sides. And we'll take the positive square root because a negative square root won't have really any meaning in this question. So we do 6,400 divided by pi. It's that number. And then we want to take its square root. Now this one doesn't have a square root, so I'm going to use the exponent key and raise it to the half power, or 0.5 power. So I do that, 0.5, and I do that as the exponent. So it's 451.352, 451.352. I did it to 3 decimal places. It wants it to 4 decimal places. Maybe I better do better than that. Let's see. Let's go 1, 2, 3, 4. So let's go 0.3517. Okay. Write that 3517. So for this one, we'll use this as our R. So again, we've got the formula over here. It's still, let me just, you go through this whole same process. This is still 1400, 2 pi. In this case, R is 451.3517. And this is dr dt. So we're just going to divide both sides by 2 pi 451. Okay. 2 pi. So that cancels. And so our answer, and just we plug this all into the calculator. And the other part that this helps with the practice is getting used to your particular calculator, because I don't, oftentimes that's where mistakes are easily made by entering it in wrong. Let's see, that looks good. We do it all, it's 0.493. Actually, they wanted 4 decimal places, right? 4936, so the 6 goes up to a 7, 4937. Okay. So that when the area is smaller, it's actually the radius is growing faster to keep up with it. And again, we could do a check on that. And there's this good. Okay. And then again, also for the test, just the test, it will be timed. It's 50 minutes from the time you start. So do get here right on, at the beginning. Actually, if you can get here 5 to 10 minutes early on Wednesday. We'll go through a run through, making sure all the technology part works for you on Monday. I'll actually have you pull up the test in WebAssign, make sure I've got all my things in a row, and then we'll open it up for more questions after that. Wednesday, we will actually just take the test. And then Friday, we'll start in on our new material, and then that last test, what we'll take as the final exam will just be the last section. So you won't have to worry, and I don't know if it's good or bad, but it just is, you won't have to study for a comprehensive final. Okay, any other questions?
Can we do number 7 for this one too?
Actually, I have done that previously. And it is in the recording. So if you look back at section 12.5 and 6, I'm going to have you take a look at that one. And there is also in the review section, there's one let's see, in fact, is it identical? Yeah, there's one like this in the review for 12.5. All right. Well, thank you guys. Have a good, this is Friday. It's hard to know what day it is. Have a good weekend. And stay safe. And hopefully this thing will break over. But again, we are already online for the rest of the semester. And we'll see how it goes. They are starting to do some fall scheduling, so I still don't know my fall schedule yet, but hopefully over the weekend I'll get that set up and I'll let you know what I'm teaching then. So
Thank you, Professor. Have a good weekend.
You too. Take care.
Thank you.
Thank you.
Thank you.
Thank you.